Okay, so welcome. My name is Terrence Barkin. I'm the Executive Director of the Graphene Council. We are today's host for a webinar on CVD and monolayer graphene. I'm extremely pleased to be joined by Dr. Kim from LG Electronics, Kevin Weir from General Graphene, and Jeff Dray from Grolltex, who will be our presenters for today's webinar. Before we get started, I'd like to tell you just a little bit about the Graphene Council. Many of you are members of the Graphene Council. Some of you are not. And we'd like to just let you know who we are and what we do. The Graphene Council was established in 2013, and over the last 7 years, we have grown to become by far the largest body for the graphene sector, including both academics and commercial professional. We have graphite producing companies, graphene producers, intermediary companies, folks who add value to graphene through functionalization, and end user companies. Today, we represent more than 25,000 material scientists from all sectors, again, from both academia and from the commercial sector. And through strategic partnerships we have with organizations like the Society of Petroleum Engineers, the American Composite Manufacturers Association, JEC Composites World, Specialty Protective Coatings Associations, etc. Through those relationships, we reach hundreds of thousands of engineers and specifiers who have an interest in graphene materials. Some of our member companies are displayed here. This doesn't include all of them because we also have corporate member companies that choose to be anonymous for commercial and competitive reasons. We're very proud to have organizations like the University of Manchester and the University of Warwick as members in the Graphene Council, as well as Drexel University and the University of Utah in the United States. And we have the major graphene producing companies, 3 of which are represented in today's webinar, and end user companies like the Ford Motor Company and others who are using graphene in their applications. So with that being said, I'd like to invite our first speaker to go ahead and share his screen. It is Dr. Kim from LG Electronics, who will talk about an interesting roll-to-roll process that they have for CVD monolayer graphenes. Okay, Dr. Kim, it's all yours. Thank you.
Okay, thank you. Good morning. I'm John Kim, working for commercialization of a CVD Graphene project in LG Electronics. Today, I briefly introduced the LG Electronics innovative roll-to-roll CVD graphene technology and our vision for CVD graphene as a new material platform. Yeah, everybody knows well about the graphene. Graphene is a very famous material due to its extraordinary property. Because of its magical property, it has a huge potential and it could be used in various fields. I believe the CVD graphene will change our life in the future. Graphene is the absolutely wonder material. However, nothing is realized yet. Unfortunately, I can't find any commercial mass production using CVD graphene. That's a big problem. What's the matter? There are many keywords relating the commercialization of CVD graphene: cost, productivity, uniformity, reliability, and there are many things. We summarize that as the following issues: cost, productivity, uniformity, performance, and reproducibility. Less cost compatibility. Graphene is largely the substitutional material, so it should have affordability to be the predominant competitor. However, CVD graphene is so expensive, so it's almost impossible to use for commercial product. Low productivity. The growth scale is another issue. It has limited its application area only for small scale application, very tiny one. The stable supply of a material is essential for commercial product. Non-uniformity. Uniformity is another key factor for performance of a final product. However, there is a large variation in its property for current CVD graphene product. Low performance. Graphene has been focused its extraordinary property, but most of the cases are shown on the ideal state. So the growth of high quality CVD graphene and realize its performance is also important. For reproducibility, so without reproducibility, almost impossible to use for mass commercial product. There are many issues to overcome for commercialization of CVD graphene. We have to find the right way to overcome that. Here is LG's way to overcome the issues of aforementioned, delaying the CVD graphene commercialization. LG Electronics offers a roll-to-roll CVD process and combined with secure quality control. So large area and high quality CVD graphene could be produced with a high throughput by roll-to-roll CVD process. That means large area CVD graphene with a high quality could be supplied at low cost. That is very, very important for commercialization. LG is one of a top-level manufacturing company, so we have well-established quality control process and lots of experience. The Six Sigma-based strict quality control process is enabled to graphene uniformity, reliability, and reproducibility. We believe LG's roll-to-roll CVD graphene system with secured quality control management could enhance the affordability, availability, and industry experience of CVD graphene. It is a positive role and the contribution of LG Electronics for commercialization of CVD graphene. There are various systems have been considered for large scale and mass production. Among them, the roll-to-roll CVD process is a more suitable process to maximize the productivity. I introduced the LG Electronics CVD graphene system. The first generation is a large scale system and is impossible for mass production. So we consider and develop the mass production system. The second generation is a vertical roll-to-roll CVD system with 150 millimeter width. The quality and reliability and reproducibility and productivity were secured, and it is operating for mass production from last year. It's a pilot scale stage, and it's a capacity about 5,400 square meters per year. To maximize the affordability and availability, we developed a large and double roll combined with a high-speed system. We complete the verification for mass production using our string rule of quality control process, and it is now operating as a pilot production stage. Its capacity is 28,800 square meters per year. It's a huge amount. Here is the actual picture of our roll-to-roll CVD system, and it's a practical product of using this system. It's a 400 millimeter width CVD graphene roll with over 20 meter length. Here is our equipment specification. The control of crystal orientation of a copper substrate is a key factor for high quality graphene growth. The vertical geometry could adjust the copper crystal orientation for optimized graphene growth. The graphene growth under tension using vertical CVD system show larger grain size and less defect. We control the grain size as shown in SM image from 5 square meter to 200 micro square meter. And we also minimize the defects such as the multi-layer dot. In this image, that is very clean. There are only few multi-dot exist, but normal case, there are lots of multi-layer dot exist in the CVD graphene sample. By enlargement of the grain size and minimize the defect, the excellent electrical performance were obtained. Yes, it is true for high performance of graphene. We are keep trying to grow CVD graphene with large grain size and zero defect. The quality control, it is a very important key to secure the uniformity, reliability, and reproducibility. We evaluate the entire product. All graphene rolls were cut at this scale, and all the samples have been checked out at least 50 points for signal resistance evaluation. As a result, the signal resistance value is about 255 square meters with 10% standard deviation. The 10% standard deviation is our LG's rule for quality control. So, and the distribution is very narrow. The grain size and layer uniformity and crystal quality and crystal orientation of copper foil are also evaluated for quality control management. LG has a well-established quality control process. It is very detailed and very strict. In order to confirm the quality of CVD graphene grown by vertical roll to CVD system, all products are evaluated as aforementioned way. The quality control process are manualized with detailed and strict manner. The product inspection and quality assurance are reported per product. LG collected all evaluation data and make a construct as a big data form. The database consists with 138 pictures for raw material, process, analysis, and evaluation. It is finely managed for quality control and process optimization. Here is the application and our vision. CVD graphene could be applied as a new material platform for ITBT industry. CVD graphene could be used in display platform, such as a transparent electrode, barrier, flexible display. Nowadays, the new form factor of display is coming, kind of the foldable display or flexible display. So we believe the CVD graphene have a chance to apply in this area. Electronic platform, high-speed RF device, sensor device. The bio platform nowadays is very focused because of the COVID virus. The CVD graphene is well-known material for bio-friendly. So it's very friendly with the tissue and cell. So it can be used for biocompatible material and biosense. Basically, we focus on developing the mass production of high-quality CVD graphene. So we are very welcome for collaboration to find the killer application. We are very good relation with our group, kind of the LG Electronics, display, LG Chemical, so we can more easy to access to that company and to more acceleration the killer application. So we are very open for collaboration. So, and it is not limited to this area. We test the flexible transparent electrode. We test the folding test. Only CVD graphene is survived on the 200K times folding with a 1 millimeter radius. So we believe it can be using in the new form factor display. Graphene can also using the energy platform for conductive barrier for chemical reaction, and for the biomedical platform. Nowadays, we find that the CVD graphene is very friendly and very good, effective in the stem cell. So we believe the CVD graphene could be used in the bio platform for stem cell application. Here is a summary. We are very welcome for collaboration to find the killer application. So feel free to contact us. Thank you.
Dr. Kim, thank you very much for that presentation. I just want to highlight what the unique, if it wasn't obvious, unique opportunity is here is we have LG Electronics who are producing this CVD graphene on a mass scale, but are very interested in making this available to others to develop products and applications. And then in turn, they have a very large ecosystem where some of those applications can be applied. So I think that's fairly unique in the world that we're operating in right now. And so with that, I'd like to go ahead and introduce our next speaker, and that's Kevin Weir from General Graphene. And I think he's going to have a slightly different take and a very interesting bit of information for us on what they're doing. Now, before you get started, Kevin, I just want to point out that many people will not have heard of General Graphene before, but you've been around for quite a few years. You've been the company's been working on perfecting this technology, and just recently, General Graphene has become publicly visible. They're a very valued member in the Graphene Council, and so if you haven't heard of this company, it's by design. They've been working on their technology diligently for years. So I just want to point that out as we introduce you. So Kevin, it's all yours. Thank you.
Really appreciate that, Terence. And good morning, afternoon, and evening around the world. And I want to thank, first of all, Terence for putting this platform together for us. And the initiative is very, very timely. And yeah, thanks to the audience for participating, because this time kind of disruptive technology and innovation has taken a bit of a backseat whilst companies hunker down and try to go in survival mode. So having more than 500 people on today it's a blessing, and really appreciate it. And also to the other participants, to Jeff, Mr. Kim, and Lars for agreeing to participate and give out this information. Thanks to you all. So yeah, I'm Kevin Weir. I'm the business development director for General Graphene. And yeah, we're General Graphene company. We're headquartered in Knoxville, which is right in the middle of the beautiful Smoky Mountains. And so when all this storm has finished, please come and visit us. You're welcome from all over the world to come and visit General Graphene and enjoy the wonderful environment that we live in here. So yeah, we'd like to present our graphene story, and I'll break it down into 5 key parts. The first, we'll talk about General Graphene and the company. We are emerging out of technology development and moving through commercialization as we speak. We'll talk about our technology, our manufacturing approach, which is a bit different than LG's. So we do it slightly different, so that will be interesting to some of you folks. And then look at the product performance that comes out of this kind of processing. Then we'll look at the target industries and give a couple of ideas of where we're trying to place this technology. That will move us into our business model and how we specifically do outreach to industry. And then we'll summarize. So I'll jump straight in. As a company, of course, we have a mission statement. This is why we are in business. And essentially, what we're looking at here is describing the focus that we're providing to industry and how we match our teams with those of industry to develop state-of-the-art products at scale. Scale, as Mr. Kim talked about, is so critical, and we're on it. So the 2 bottom lines there is basically what we're about. What we want to do is to manufacture application-specific graphene sheets, so not standard products, that are consistent at industrial scale and at magnitudes of lower cost. This is what General Graphene is about. So looking at a bit of the history of how we got here, we've been very fortunate that our management has been able to raise more than $20 million from the investment community. And we're also very fortunate to have a very supportive strategic investor. Now, this has allowed us to kind of focus on our strategy, which again is the industrialization of application-specific, consistent, and low-cost graphene sheet. So we're well along this path to realizing this, and we regularly produce volume roll-to-roll graphene sheet, and I'll show you a bit more about that in the next slides. So this webinar is actually timely because now is the right moment to ready industry for product availability, right? So we need together to build the pipeline of new product developments today in order for the demand to meet the upcoming supply. So talking a bit about our capabilities, beyond the manufacture of large sheet graphene, we offer a range of support services which provide characterization metrics, and we measure the performance of the graphene for specific applications. To analyze and quantify the nature and key performance parameters of the graphene, our scientists and technicians employ precision Raman and scanning electron microscopy. We use optical microscopy and conductivity testing using 4-point probe, amongst lots of other tests. Now, this information then is critical to the development of application-specific graphene synthesis recipes and ensuring that our roll-to-roll product quality control and consistency are good. Our graphene transfer expertise includes a variety of wet and dry transfer methods, including electrochemical, water vapor, and chemical etching techniques. Moving to prototyping, we use the customer's substrates, and then we create application-specific graphene-coated prototypes, and then measure their performance against the test conditions that the application requires in the field. Then finally, in collaboration with our customers, we direct our engineering group to develop the industrial-scale graphene integration processes tailored to the customer's specific product and environmental needs. So let's dive in a bit to the technology. So I have a schematic up front. Unlike Mr. Kim, due to the sensitive and proprietary nature of our specialized equipment, we've substituted that with this simplified diagram. So apologies for that. So general graphene uses a different process than most other CVD graphene producers in that we grow our CVD graphene sheets under atmospheric conditions, so without low pressure and vacuum. Generally, we utilize metal foils up to 300 millimeters wide in continuous lengths and spool it roll to roll, similar to what you saw before. In short, during our process, we prepare, etch, and anneal the foil substrates, encapsulate the foil in a proprietary enclosure system, and then send the system through the equipment at high temperature, during which a mix of gases, including hydrocarbons, contact the surface and initiate the single or multi-layer graphene crystals. So our process is relatively flexible. We don't have the confines of vacuum, and this allows our scientists and technicians to tailor the crystal size, its coverage, the number of multi-layers and defect levels, and able to tune those. With this process flexibility, as I said, we can tune the properties to meet the needs of the specific application. So the resulting graphene is very useful for barrier films and filtration media and demonstrates additional useful properties, including transparency and conductivity, strength, and lubrication for other applications. So what I want to stress, most important, is that the advantage of this process is our ability to make consistent graphene at very high speeds, which means low cost. And this is the breakthrough that enables industrial volumes to be made affordably. So let's talk about the products. So on the left-hand side, we have product properties. The right-hand side, you can see some of the finished products themselves and the spool-to-spool graphene sheets. So starting with the above table, this dashboard presents us the snapshot of graphene characteristics typically measured in our laboratories. We don't make standard products, so this is showing the range of properties we will typically test. So in the top table, note that we design a wide range of graphene properties tuned to the very specific customer applications. We are able to change crystal size from large to very large crystal sizes. The ones you see there are between 40 micron, and we can produce crystals greater than 1 millimeter in width. We can also alter the surface coverage precisely and precisely determine the number of layers, control the incidence of multi-layers and other defects. So moving to the lower part of the table, the optical transmittance of monolayer graphene is about 97.3%. With 5 layers, the optical transmittance remains typically 87.2%, and even 10 layers of graphene offers an optical transmittance of 76%. Typically, monolayer graphene offers a resistivity of 635 ohms per square. Multi-layer graphene, however, offers a resistivity as low as 50 ohms per square, and when properly doped, the literature supports a resistivity of less than 25 ohms per square. Finally, notice that a single layer of graphene improves the barrier properties of some substrates by a factor of 4, and multi-layer graphene, when paired with certain polymers, is both ultra-thin and virtually impermeable. So summarizing the benefits to industry, single and multi-layer graphene is an effective, very thin barrier material that is transparent and conducting. Its biocompatibility has been well established, and graphene can also add strength to composites and act as a surface lubricant. So how are these properties being applied to industry? Well, this dashboard describes 4 key industry areas where we either have active projects or are shaping projects in our new product development pipeline. On the theme of conductivity, our films have values in excess of 2000 watts per meter per degree in the XY plane. This property can be exploited where thermal management is important, for example, in microelectronics and automotive composites. Graphene has important resistance properties, and we reach 50 ohms per square depending on the component's transparency requirement and number of layers. And this property is particularly attractive, again, for transparent conductors. Moving to barrier films, our graphene-based barrier films have been shown to reduce the permeability of various gases such as water vapor, oxygen, and even helium up to several hundred times, depending on the number of graphene layers or its transparency and the polymer substrate type and thickness. For example, we are currently using these properties to develop desalination membranes that retard the rate of biofouling. And in another example, we have produced graphene polymer laminate composites with a tunable effective electronic conductance up to 10 Siemens per centimeter, and increased tensile strength and modulus of the polymer by up to 50%, depending on the number of graphene layers used. So you can see that graphene performance can be developed to tune to many different application challenges. The key here is finding a problem that's so important that it's worth solving with graphene. And that means the performance improvement and or cost savings or your competitive advantage must exceed the efforts, the resources, and the investment required to develop the application. So with that, that brings us nicely towards our business model. So if you look at the image, we have the customer understands the need. So in the top right, the customer understands the need. In this case, for example, faster charging of an electric vehicle. General Graphene understands the capabilities and potential of graphene to improve a specific performance. So that's on the left-hand side. And so we come together on the right-hand side to match the insight of industry with our technology, and we co-develop an improved component. We have developed our specific engagement model based on open innovation outreach, and we manage it through a series of stage gates agreed with our partners. Because much of the development work is new to industry and uses new materials and processes, the need to quickly test, analyze, and iterate to prove prototype performance and profitability is critical in accelerating development and minimizing development cost and project risk. So most often there are 3 to 5 phases. Phase 1 is typically performance needs and cost target screening. Then we move to an application-specific graphene product design. Then we will move to prototype development and testing, then industrial scale-up, and finally, the commercialization of the product. The costs and resources are shared between the companies, which supports funding, promotes collaborative buy-in, and the acceleration of the project's timeline. So to summarize, we have described the company's approach to tackling the barriers to industrial commercialization of CVD graphene sheet. Again, General Graphene's focus is making application-specific graphene sheet at scale, graphene which is consistent and magnitudes lower in cost. We do this while maintaining a focus on industry-specific graphene needs and offering our expertise in characterization, prototyping, and collaborative engineering to support industry in managing this new material from development through to commercialization. And I want to finally say that CVD graphene is here today. And we would like to send, like Mr. Kim, an invitation to industry to reach out and contact us and our graphene peers and engage with us to learn more about how graphene can enhance your products and its competitiveness. And that's what I have. Thank you.
Well, Kevin, thank you very much. I appreciate that. I think the one point I'd like to highlight, and Jeff, go ahead and start to share your screen if you like. What we heard from the presentation, one thing I'd like to point out, and we've seen this from our experience with other forms of graphene, and we all know that graphene, we have this monolayer graphene, CVD produced graphene, which has very specific application areas for which it's suited. It's very exciting to see that we have several producers of this grade of material. But what is true, regardless of what type of graphene you're dealing with, the joint development of applications and solutions is definitely the way to go, because there are so many nuances and specific issues with handling graphene. And these kind of producers, whether it be LG, General Graphene, or Grolltex, are experts in the material, and it's important to work with them together on application development. So with that, I'd love to introduce Jeff Dray, who is the CEO and president of Grolltex, who have many years of experience with this type of material and have continually made really important advances. And we'd love to hear from you. So Jeff, if you're ready.
Great. All set, Terrence.
All right, Jeff, all yours, man. Go ahead.
Thanks very much, Terrence, for putting this on. Much appreciated. Thanks everyone else for being with us today. Pleasure to speak with you. So my name is Jeff Dray. I'm CEO and co-founder of Grolltex. Grolltex is short for Graphene Rolling Technologies, and the reason for that name will become apparent very soon. For some context, we're located in San Diego, California. We're a spin-out originally of UC San Diego Technology. My partner and co-founder, Dr. Alex Zaretsky, was a researcher there when he came up with the idea for these technologies. So what you're looking at here is kind of the reason that we started the company at all. The incredible advancement in 2010 of buy and or Ruoff of using CVD to make high quality sheets of large area monolayer graphene was really an important step forward in the world of graphene, of course. But you know, if you ask the question, why hasn't this technology proliferated with all the terrific work by LG and others of making CVD graphene faster and higher quality and bigger grains, why hasn't this material proliferated? And one of the big reasons we believe is the next step down the line, that's transfer. When you're making your high quality CVD graphene on copper, the next step down the line is getting your graphene off the copper. Today, the state of the art seems to be acid etching copper. That's expensive, it's slow. We don't think that's the way forward. And so Dr. Zaretsky spent a lot of time thinking about this and came up with what we think is a very important piece of the puzzle in advancing CVD graphene proliferation, and that's solving this transfer issue. So we have a patented process to remove graphene from copper and not destroy copper at all. We reuse the copper growth substrate, and as it turns out, the more times you use the same piece of copper, the better and better quality graphene you get. Our process can be done on a roll-to-roll basis, meaning it can be done in minutes versus the sometimes hours it takes to acid etch copper. And the equipment it takes to do our process is off the shelf. It exists in industry today, very well understood processes. This is kind of what it looks like. So what you're looking at here are the three basic steps it takes for us to make graphene. Step one on the top, of course, is CVD graphene synthesis. CVD, again, very well understood process, been used for decades. Step two, this is where our kind of patented secret sauce kicks in. We metallize that graphene on copper. And the reason we do that is this nanometric layer of, in this case, nickel or cobalt, has a 7 to 10x adhesion rate as compared to the copper. So in other words, the graphene wants to stick to this new nanometric nickel layer more than it wants to stick to the copper, much more. So we put this nanometric metallization on top of the graphene, grab the graphene, pull it away from the copper, and then on a roll-to-roll basis, that copper can go back in the line to make new graphene. So that's step two. Step three is the equipment that this is basic roll-to-roll thin film processing equipment. Again, these are processes that have been around for decades. If you think about this roll-to-roll process, it's really nothing more complicated than if you open up a bag of chips and you see in your potato chips inside that the inside of that is metallized. So that's the scale of the roll-to-roll films we're talking about. So to summarize this slide, we believe that the science, from our perspective, the science is done for transfer, and what's really needed now is to spend the time and to do this when there's a market need. Here's what I mean by market need, and I'll just speak for our example. When we started the company 5 years ago, we thought that the first breakout application for what we were doing was going to be displays. Of course, the display makers were going to want flexible displays made out of graphene. That was our path at the time. So we went out and talked to all the display makers, all the big folks that you know. We also went one layer deeper and talked to their films providers, the electronic films manufacturers of the day. What you're looking at here is circa 2015, a representation of what the future display materials roadmap was at that time. And as you can see, graphene is on there. So when we talked to the display makers and showed them what we were working on, they all said, hey, this is great. What you're working on is very important. Come back and see us in 10 years and we'll have something for you. We were probably 2 or 3 nodes early with what we were presenting. So, you know, we were a startup at that time. 5 years ago, we said, you know, we can't wait 10 years. We have to figure out something else. So we shelved that for now. We still have this technology, obviously, but at the time, we had to make a business out of our business. So we embarked on what we called a 2-phase business strategy, and then we started phase one. Phase one is doing what we're doing today, which is we opened a retail business of selling small quantities of research materials to labs all over the world, university labs, commercial labs, government labs. So we sell small quantities of 2D materials, graphene, HBN, and others. And the reason we did that phase one was to really conduct a worldwide market survey, real-time market survey of what people were doing with graphene. And with that information, we would launch phase two. Once we saw what the breakout applications were going to be, letting the market tell us that, we would launch phase two of our business and go after those markets that were buying all the graphene from us. So if you go to our website today, you'll see that we still sell graphene in small quantities. We sell it in 3 formats. Number one, we sell it on the copper that it's grown on because a lot of people want to do their own transfer. Number two, we sell graphene transferred on bare silicon wafers, 4-inch, 6-inch, and 8-inch. And in probably 3 or 4 weeks, we'll be doing 12-inch as well. We just finished reconfiguring the fab to do that. And then on the upper right, the third format is we transfer graphene onto your substrate of interest. So customers send us their planar substrates. We transfer graphene on them and send them back. We actually do a good bit of business that way. So those are the 3 formats that we sell graphene. On the bottom row there, you can see we do the exact same thing with HBN. HBN, of course, hexagonal boron nitride, and this is the insulating complement to graphene as conductor. So now if you're an electronic device designer and you want to do something with monolayer materials, you've got both the conductive layer and the insulating layer, okay? So we've been doing this now, this phase one business, selling lab materials on a retail basis. We've been doing this now for about 3 years. And these are some of the customers we've sold to. On the left, you can see university labs. In the middle there, you can see commercial and government labs. On the right is a list of prior competitors that are now customers of ours. So really proud of that list. So I said that we've been gathering market data from all these sales that we've been making all over the world for the last 3 years and gathering, you know, what are people doing with our graphene? What are they making? What specs do they care about? What do their final products look like? That kind of thing. Let me share some of that market data with you. On the left-hand side, in the blue part of the pie chart, you can see that a little over half of everything we sold has gone to all kinds of incredible use cases, things that you would imagine people would do with graphene, right? Advanced solar cells and heat sinks, surface enhancement, proton exchange membranes. I could go on about this stuff for hours. Very interesting stuff people are doing with our material. But on the other side of the pie chart, a little under half of everything we sold, about 40%, has gone to one application, and that application is sensing. And almost all of that is biosensing. Now that's a really good story for us. Number one, because it's a big, big market. Number two, it's very high margin biosensing. And number three, it's a very high demand specification. Biosensing requires a highest quality form of graphene, and CVD graphene, of course, is one of the highest types of graphene that can be made. So this is a great fit for us, this biosensing market, and we've been pursuing this now for several years. For example, on the left-hand side are customers of ours where we're the material supplier. So we supply the raw material here, and these customers on the left-hand side square make their biosensors using our material. Terrific applications, all of them growing. On the right-hand side are customers that come to us with their designs, and we actually make, as a foundry, we make the graphene biosensors for these customers. So again, on the left-hand side, we're the materials provider. On the right-hand side, we actually make devices here for customers that bring us their devices on a foundry basis. So here's one other interesting thing I wanted to relay before I summarize and open up for questions. We've done a deep dive into our customers' designs, customers that make biosensors on silicon. And it turns out that it's very, very expensive, as you can imagine, to make your graphene-based biosensor on silicon. First of all, doing anything in the silicon environment is expensive. Second of all, some of the packages that are used to put silicon chips in and make that useful are also very expensive. So it's a high cost of doing business to make your biosensor on silicon. Well, it turns out, I said we did a deep dive, it turns out that many of our customers, most of them in fact, their designs don't have to be on silicon at all. They just went to the silicon infrastructure because, you know, that if you're going to go make a nano device, today the silicon infrastructure supports patterning and etch and deposition, et cetera, at the nano scale. But if you don't have to make your device on silicon, it's much, much cheaper to, what we did, make them on plastic. So we have been making several of our customers' designs now, graphene biosensors on plastic. And also, this opens up a whole new world of form factors available to make graphene sensors. And I'll show you what I mean. Before I finish this slide, one obvious benefit is that in many cases, we can make this graphene biosensor for 100x cost savings over doing business in the silicon environment. Much, much cheaper to make your sensor on plastic. So second to last slide here. These are the first three form factors that we came up with of graphene biosensors on plastic. I'll run through them very quickly. Upper left, form factor number one, this is a blister pack. This is like you go to the drugstore and get your Advil, you pop the pill out of the blister pack. Same thing here. In this blister pack, there's a graphene biosensor. The blister does two things. Number one, it protects the sensor environment until you're ready to use it. Number two, this allows you to pre-charge this blister with some functionalizing chemistry, getting ready for the analyte of your choice. So a use case for this might be, for example, a farmer in the field who wants to do a very quick test on some of his crops, determining crop health. I didn't just make that one up, by the way. That's a real customer use case. We had someone come and ask us for that. So we can make these blister packs on biodegradable plastic. Farmer keeps this in his pocket, throws it away when he's done. Form factor number 2. Imagine a very similar sort of blister pack, a little more rigid, but now it's in a sheet of 100 of these sensors, and this fits into the 96 well plate format that pharmaceutical companies use to automate their testing. So this is plug and play for the drug companies to do automated testing with graphene sensing. And then form factor number 3 on the right-hand side, this is the one I'm most excited about. What you're looking at there is a microfluidically plumbed, multiplexed array plastic chip. Now, let me break that down. Microfluidically plumbed, meaning it uses very, very small sample size. You don't need hardly any biology in there, measured in like nanoliters. Multiplex, meaning each one of those, on that chip, there happens to be 5 sensors. We can double or triple the density of that. But on that chip, you can program each of those sensors to do a different test. So for example, that little plastic biochip could be at points of entry all around the United States or wherever. And as someone comes in, it could be used to test for a common flu virus versus a SARS virus, COVID, whatever. So multiplexing is something that diagnostic people have been looking at for a long, long time. This can be done very inexpensively. And again, multiplexing, big deal. It's a big deal for diagnostics. So to summarize, Grolltex is ready to support CVD graphene transfer at high volumes. Again, you've seen lots and lots of great work. You just saw LG's work at high volume CVD production. There needs to be a transfer component of that. From our perspective, we've done the science of that. We've proved it to our, we have an alpha unit of that rolling tool. We have a beta unit here. And when the market comes and says, we're ready for high volume CVD graphene, as you've heard other people talk about, we're the transfer guys. We're ready to do that. Now, but again, pivoting to summarize, for the last 3 years, we've been doing this phase 1, phase 2 business, and the progression has been, number 1, to sell research materials to labs all over the world. Number 2, transition that a little bit to specific sensor materials. And now number 3, we are a biosensor foundry on plastic focused company right now. So if you have any questions about either of those 2 things, about high volume CVD manufacturing and transfer, or if you have questions about sensors on graphene, happy to talk about that at any time. Contact information here is support@grolltex.com. I'm the one that answers those emails. Those come directly to me. And I think Terrence is going to open it up for questions here anyway. So happy to turn that over to Terrence. Thank you all again very much for your time. Terrence, thanks for putting this together. Very much appreciated.
My pleasure. Thank you, Jeff. And you and I have known each other now for a few years. And I just want to say congrats on all the progress that you guys have made over there. It's very impressive. I'm going to do a very short commercial while we still have everybody's attention, and then I'm going to go to the Q&A. So the Graphene Council has produced a graphene report, which includes covering CVD, forms of graphene, and application areas. This report is included in corporate and university membership, which tells you that we have memberships for both corporations and for educational institutions. Our university membership will cover all of the faculty and all students. So that's a great benefit for academic institutions. And for corporate members, you not only get the graphene intelligence in the report, but we do a weekly graphene intelligence briefing on commercial developments, research developments, and as well as patent filings worldwide, which is quite interesting to see where the trends are going. And we're going to have an upcoming presentation on a review of the more than 2,000 patents filed for graphene over the past year and what that tells us about commercial development. So what we're going to do, we have our panelists. We have a whole bunch of questions, and Lars, you are unmuted as well. Lars is from LG, so if you want to chime in as well, if you have something. We have a boatload of questions, but let me start with some general themes that have come through. And you've addressed this, each of you have kind of addressed this in a way, but there are 2 questions that come through. One is about the quality of the substrate. And I know that that's a huge issue with the crystallinity of the copper and what if you're using copper as a substrate. But can any of you discuss or want to talk about the importance of the substrate and how you maybe treat it, enhance it, if it's annealing, or work with it to get the best possible outcome in terms of the graphene crystals that you're growing?
Sure, I can take a quick look at that. So, Terrence, you kind of actually touched on something important, and other CVD growers will talk about this too. You know, from our perspective, you saw a little bit about the transfer idea that we employ, and one big thing that's different about how we see the substrate versus other folks is, I think a lot of the paradigm in wanting to use CVD graphene that's grown on copper is, okay, now we're done with the process. Here's the graphene, copper bad, get rid of this. I want my graphene, right? So that's sort of the mindset, copper bad, get rid of it, metal bad. And we have a very counterintuitive approach. We say, no, copper good. Don't throw away that copper. If you spend a lot of time preparing the copper, which we do, running pre-processes and polishing and cleaning and annealing and all kind of stuff, and there's literature that shows what to do, then that copper is very valuable. Well, since we employ the idea of transferring and keeping the copper, that's especially important for us. So copper not bad, copper good. Okay, that's the way we have to think about it going forward. I know not everybody uses copper, there's nickel too, but the point of that is the growth substrate, if you're going to spend a lot of time doing the prep, and again, there's a lot of literature showing how and why to do that and the results. If you're going to spend the time to do that, keep the copper. Let's not etch the copper, right? That's not the way forward.
Right. And Dr. Kim, I don't know, do you have a comment you want to share?
Yeah, I agree with Jeff's opinion. Basically, we using the copper foil, but we don't using the pre-treatment. As mentioned before in my presentation, we using the vertical geometry. So the tension is applied the copper foil. So by the tension effect, the crystal orientation of copper foil is adjust one direction. Is the most optimum crystal orientation for graphene growth. So we don't using another treatment. So we think the tension is a good way for the best quality of the CVD graphene growth using the copper foil.
Excellent. Okay. And Kevin, I don't know, you would need to unmute yourself, I believe, if you want to contribute to the discussion. And I understand, you know, I think what's interesting with the approach that you had shared is you're not necessarily always depositing on copper.
Yeah, for the single layer graphene, we're depositing on copper, but we do a lot of multi-layer graphene as well, or graphite in that case. And then that's done on nickel catalyst, yeah. Okay.
Excellent. There was a question, and I know I've seen some reports recently, we haven't discussed it necessarily here, about using CVD graphene or using graphene as a separator in fuel cells, right? In the passing of, I believe it's protons through graphene. Is anybody working on hydrogen fuel cells in graphene?
We have had some of our customers, you know, I put up a graphic there that showed what people are doing with the graphene. We've been selling retail for about the last 3 years. And that is one of the use cases. We have had folks buy our graphene and want to work with us to employ it for proton exchange membranes. Yeah. And in fact, I think Geim has done a bit of work that's published too, that he sees this as a really important future use for this material. There's some engineering difficulties around that. It's not a simple way forward, but you know, in a perfect world, that's one of the things that should be worked on right now. I don't know who's going to pay for that or push it forward, but you know, on a theoretical basis, yeah, that needs to be pushed forward. Graphene as a PEM, you bet, that needs to be worked on.
So it's kind of interesting, and I think you've touched to it. So one of the questions deals with, okay, there aren't large-scale CVD graphene applications today necessarily, although obviously there's probably more than people were aware of. And we have seen this issue of, you know, it's been so cost prohibitive that it prevents people from starting. One of the things we wanted to do with today's webinar, and hopefully that's come through, is the fact that we have 3 different companies that are all quite active in development of high quality, large scale CVD materials is something that frankly a year ago we couldn't do, right? So this is available now and today. And I think from some of these other examples, there are some really exciting applications. And in particular, now I'm going to talk to you from the Graphene Council's perspective, because we monitor what's going on in this sector globally, and we get a lot of input from the end use side, and we also see what's going on in the academic literature. Sensor technology is one of those areas that we think is exceptionally exciting and has a lot of really good applications. And then everybody's spoken about biomedical, and of course, we're dealing with a carbon material and its biocompatibility. So, it's always the chicken and the egg. If it's too expensive, then industry doesn't adopt it. If industry doesn't adopt it, there's no market for it. Do any of you want to talk about, kind of like this tipping point for CVD graphene, where now, I think, Jeff, you were talking about getting down to $5 per square meter. That's a phenomenal price point. Are we at a tipping point now where CVD graphene needs to be embraced by industry?
Well, it needs to be. I hope you're right. Yeah, I hope folks are going to get on board. Again, from our perspective, I talked about sensors, mostly biosensing, but quite frankly, there's some other sensing that's being done with our materials as well. And so, for example, we have a joint development program working with a large Japanese conglomerate that wants a strain sensor, and their application is it's a structural health monitor, and their application is train wheels. So wheels on high-speed trains. They want to use graphene sensors embedded in the materials of the wheel to sense, any micro strains taking place in that material. So there's some other thinking going on in sensing as well. I would like for nothing more, and I'm sure Dr. Kim feels this way too, for the display industry to raise their hand and say, yeah, we're ready. We're ready for miles and miles of graphene. Count me in. We're all over that. That's why we started this company. But since that's not happening, got to figure out a way to make a living, right? And right now, that's for us, that's sensors.
The large industrial applications that really are using where roll-to-roll sheets of this product would be applicable. So you can think about energy storage opportunities there, some electronics applications particularly, and also a lot of filtration applications. And we can't talk too much about them because of, non-disclosures, etc. But it's really applications where, when we do the coating or transfer, it's at this large scale. Again, it's very difficult if we're doing bits and pieces of business. And so we're looking for those industrial applications that really require this really large volumes. That's how you get the cost down to these $5 to $10 per square meter kind of value. So it can be done, and we've shown today that we can do it. There's 3 examples today that it can be done. So where are these large industrial applications out there? Now we've identified what they are, and we've talked about them in various electronics and energy storage, etc. Transparent conductors. There's a lot out there. What we need is those industries to come forward and say, yeah, here is a challenge. We want to differentiate ourselves, or we have a problem. We need to eliminate a material and substitute it for that, or we need a better performance. That's typically the situation. You're going to substitute an existing material, you're going to increase performance, or you want a competitive advantage. That's the 3 reasons why people come to us. And yeah, that's why we go through our specific business model, where we then partner with those companies, co-invest in the application development, and move it out at high volumes. And the first part of that is doing the cost screening. So we don't necessarily say we're going to sell it for $100 or $10 or $5. What we figure out is what's the value being created, and we share that value with the customer. And that's our way of doing it, because we don't want to have a run to the bottom deal. We don't want to be making like the carbon fiber industry happened. It takes 12 years for a carbon fiber company when they invest to make money if they sell out the plant. So we don't want to get into that situation. We need to offer value to industry on large scale so that we can reduce our costs. They make a ton of money out of it and differentiate themselves, have high performing products that society is benefiting from, and we can make a good living out of that. And that's the way we should proceed forward, I believe.
Absolutely. Dr. Kim?
Yeah, I think There are important thing is people believe CVD graphene is so expensive. They don't believe CVD graphene is possible for mass production and low cost. So
Yeah.
people don't try to using the CVD graphene for real application. Only tiny one, kind of sensor one, that kind of small scale. But people have to know that CVD graphene could produce in mass production and low cost. In our company can produce lots of scale meter. It's a capacitor for large scale application. That one post people know that, and there are some challenges necessary. So to overcome some prejudice for the CVD graphene and the new challenge. Every guys working in graphene area, working for display or many kind of the normal conventional application. So we believe there are new challenging or a new idea and new breakthrough come realized in the soon time. So we hope the collaboration about that, and after 1 kilo application exposed to commercial product, and it could be more application can be realized.
Yeah, I think if we look again from the Graphene Council's perspective, we're kind of looking at where the demand is, and also there are some, let's say, sectors with the bulk graphene or the multi-layer graphene markets that might show a way for you guys as well, are things like coatings, anti-corrosion. If you think of things like hydrogen, high pressure vessels, pressure vessels, that really need some barrier properties. I know there's a lot of interest from the oil and gas industry because of the highly corrosive environment in which they operate for pipelines. These are some interesting applications. If you think of films, especially like films for food containers to stop permeation, that would be a high volume use. We spoke a little bit, and Jeff, I think when you talked about HBN and graphene used together, there are a lot of heterostructures or other 2D materials that can be used in combination with graphene. So for example, transparent electrodes, so for photocells to make them more effective and efficient, and use graphene in combination with other materials. So I think one message or a takeaway I'm hearing from you, we never want to undervalue or cheapen the product, but I think the message is that graphene now can be made at a large enough scale and an economic cost that companies who have just dismissed it as being too fringe, not mature, too expensive, need to come back and take a look at this and look at how to work together with you guys to develop applications. And we've seen in the bulk graphene market, the value is not in the material itself. It's the value add that it enables in what product you can develop it. And so if you put all these attributes and monolayer graphene, so sorry if I kind of go off on a tangent here, all the hype and all the superlative things that we heard about graphene apply to it as a single atomic layer. And this is the type of material you all are making. And so it has those greatest attributes for heat dissipation, electrical conductivity, barrier properties, and strength enhancement, and others. And so I think this is very exciting to see that there are multiple sources of supply for this type of material. I'm going to ask one more question that does come up again and again, and it is this transfer process. And you've got each a little bit a different take on it, but the ideal is very large scale, defect-free material that then you can transfer without damaging the material in the transfer. Can you each just kind of take another take on that and what the current state of the art is in terms of transfer, and maybe talk about the range of substrates that could be transferred to or applied directly to? Maybe Jeff, do you want to start first with that one?
Sure. So again, we consider ourselves the transfer guys. You can't do any transfer until you've done synthesis. So we obviously do a lot of that as well. But from our perspective, transfer can be done in a number of ways. A lot of them are out in the literature. In fact, quite frankly, our what we call MAE or metal assisted exfoliation. Our transfer process is in the literature as well. Our patent is public. We posted it on the website. Peer-reviewed papers for our process are on the website as well. So for transfer, very quickly, I talked about metallizing the graphene that sits on copper, and the reason you do that the graphene wants to stick to this new metal layer more than it does to the copper, pulling it away. If it's done on a roll-to-roll basis, and there's obviously some engineering work to be done there. It's not a trivial thing. For example, one of the things to consider is the radius of curvature of this rolling apparatus that's going to pull the new metallized layer along with the graphene, pull it away from the copper. So it's not, again, it's not a trivial engineering exercise, but we have demonstrated it. We published the paper. We have the tools in the back. We're ready to do it. One other thing I want to talk about too, and it's because I saw several chat bubbles go by asking about graphene as an electrode. When we employ this metallization process, for example, one of the recipes is 20 nanometers of nickel on the top of the graphene, grab the nickel, pull it away, then the copper goes back in the line. Now you've got this metallized graphene. What can you do with that? Well, as it happens, we can pattern this nickel layer into electrodes, sensors, all kinds of interesting things. It's already on the graphene. Also, the graphene can act as a barrier layer for that electrode if you want to do it that way. We have, in fact, a grant. We're working with a team at the UC San Diego. It's a State of California Energy Commission grant, where we're coming up with a new version of a perovskite solar cell that in fact uses the electrode that I just described, where the graphene poses as the barrier layer. If you're familiar with solar cell technology, a lot of money, perhaps 30% of the cost of a solar cell, is spent with encapsulation or barrier material. And if the graphene's already there and it's the best barrier material available, then why can't that be the answer? So that's one of the projects we're working on. But again, the reason for my bringing it up is that there are lots of answers to be able to work with graphene and create terrific electrodes through patterning with these other metals on top.
Thank you, Jeff. And Dr. Kim, do you want to talk about transfer?
Oh, actually, we didn't develop the transfer method. There are lots of many kinds of transfer methods for PMA-based or the kind of specialized in the metallization, kind of the Grolltex. Actually, the important point is the high quality CVD graphene and good method to transfer. So we only focus on the growth method. So we wanna find some good partner or collaboration for the good transfer method. So that will be good synergy. Yeah, we believe the company like the Grolltex.
Excellent. Well, it sounds like you guys need to work together. And Kevin?
I would only say that Jeff definitely has the most expertise in this space right now. He's got some nice technology sitting on the side that could be further developed and be very useful for the fast industrial transfer. So we're having to go through this process right now because some of the clients that we have are very, very large volumes roll to roll. And so we're working with them. It's a little bit proprietary, but we're working on it. And hopefully by the end of this year, we'll have some more news for the Graphene Council on how we've managed to do that. Excellent.
Well, I think this is a good place to leave it. We still have tons of questions. I'm going to share those with our panelists post-event. We'll see if we can maybe write up a report on what we've discussed today. On behalf of the Graphene Council, I want to thank our panelists for the participation today. And the message is definitely going to go out from us loud and clear as we go on that, CVD graphene for commercial scale production and application has arrived, and that we have excellent partner companies to work with to develop these. Gentlemen, I'll start with you again, Jeff, on my left to right. If you have any last comments you want to make before we sign off.
Thanks again to everybody for attending. Thanks, Terrence, for putting this through. How about a special shout out to Dr. Kim? It's got to be, is it midnight or 1 in the morning for you? Wow, you are tough.
Yeah, actually, it's already Friday here.
Well, thanks for being here. You're tougher than me.
And Dr. Kim, any closing remarks from you, sir?
Yeah, first of all, I want to thank you for the Graphene Council and Jeff and Kevin. Yeah, it's a very great time. We think it's a great chance to know people. The CVD Graphene is already matured technology, and it can be ready for commercialization. Yeah, it is a very important thing. Thank you.
Well, thank you, sir. I appreciate, again, and echo Jeff's comment. I know it's quite late, so thank you for joining us. And Kevin?
I just, here's the thing. We're progressing on the graphene manufacture. We're getting it down to low cost, and it's at volume. So that's an important point. The thing is, every 3 months, every 6 months, we're making more and more progress. We're going to make progress on transfer as well. So what we need right now is this application development. We all know that once we get together and we have a project, right, it's going to be 6, 9, 12 months before we've gone through all the validation stages and get a product which is market ready. So we're trying to hit the puck to where the skater is skating to, and we need your help with that. So reach out to us. Any of you that have very specific projects and you have products that you're designing and going to make with a pull from the market and the industry out there as well, you know what you have. This hopefully has sparked in your mind, yep, okay, I've got that problem. I think graphene might work. If not, let's explore it. Reach out to us 3, and let's see if we can figure it out with you now, so that at the end of the year and beginning of next year, we've got your products on the market.
Excellent. Thank you, Kevin. And so from the Graphene Council, we're going to sign off today. Thank you for listening. Again, think about joining the Graphene Council if you're not a member of our organization today. These are the kinds of things we do. We bring parties together to help commercialize and advance the development of graphene for the betterment of all of us. So thank you for your attention. And especially in these times, please stay safe and stay healthy. We want to see you again. All right. Thank you all. Take care. Have a great day.
Thank you.
Thanks.
Take care. Bye-bye.